Hello, hello everyone. So today we're going to go over derivatives. We're going to learn about derivatives. So what is a derivative? So a derivative is the rate of change in the rate of change of something in an instantaneous moment of time, let's say. So rate of change. What do we know about rate of change? So one example of rate of change is the slope of an equation. And how do we calculate that? So let's say we want to get the rate of change of y compared to x. So how much y changes in accordance to x, right? So what would we do there is the rate of change in what we have here is 2 points, right? So let's call this x, and then we can call this, let's make this a length of d. So we can just make this x plus d. And then what we have here is, let's call this equation f, right? Let's call this equation f. So this point here would be f of x. When you plug into the equation for this line is f, so this is f of x, and this is f of x plus d. All right, so how are we going to find, I'm trying to find the rate of change, right? So let's just start with the concept of the rate of change, and then we'll go into like an instantaneous rate of change. So the rate of change of, I guess the y here, or like compared to the x, would be rise over run, right, guys? So how much y changes over that time, f of x plus d. So we get the second point. So we're trying to get the amount of change from here to here in terms of y. Just trying to get this minus f of x, and then we're going to put over that over how much x changed over that time, and we just know x plus d minus x would just be d, like it changed in a matter of d. Like that's amount. So this is rate of change, right? What would it be an instant though? Less than 1 second. It's less than 0.1 seconds. It's very tiny. It's pretty much almost zero. So what we're trying to find here is when x changed by 0 amount, how much did y change? By pretty much almost 0 amount. Like how much was it changing exactly this tiny point, like extremely, like infinitely tiny point, right? How much was it changing right then? And what was the slope, right? So how much was y changing compared to x? So if I plugged in 0 for d, that would not work, right? Because if I were to plug in 0 for d, then I would, I can't divide something by 0, because 0 times anything would just be 0. So it just wouldn't work. Like that would be not an acceptable form of equation for this. There's something I can do, and that would be, I would make the limit of d pretty much approach 0. So I can kind of do this to represent what a derivative is. The rate of change, this is dy over dx. So how much y is changing at that instant compared to that instantaneous change of x. So let's say I'm going to make f of x equals x squared, right? Let's do a quick example of this. So we have our equation right here. We're plugging x plus d into f. The first part is x plus d squared. So f of x, this term right here, or this right here, is equal to this right here. Minus, I'm plugging in x into x squared, so it's just going to be x squared. And I can do this all over d, right? And then I can kind of break down quickly, take down this equation, use the distributive property, and let's see. So I would multiply x plus d times x plus d, and I would get this equation right here. Then I get minus x squared. Then I get it all over d. So now what we have is we can cancel out these. So we don't have any, we can do x squared minus x squared. So we don't have any more x squareds on the top. And then once those are gone, we realize that we can divide the equation by d, because all of them, once those are gone, we only have this. So we can just divide d from the top. And then what do we have left? I have 2x, because once I divided 2dx plus d squared by d, I have 2x plus d is left. And we know that d is approaching 0. So in this equation, we can plug in 0. Because if I do plug in 0, it's still gonna like be a valid equation. I'm not gonna get like anything that's like, I can just plug in d for 0, and I'm not gonna, it'll still be a solution. It'll still be a solution. And so at the end, we find that the derivative of x squared is right here. It's 2x. At any point of time, let's say we have x squared, right? Let's say I want to find how much x squared is changing at exactly when x is 1. So when x is 1, x squared is changing at an instantaneous rate of 2. So it's increasing by 2 at that moment. So what about how much it's changing when it's 3? So that one, I plug it into the derivative. It would be changing at a rate of 6. X squared would be, so it increases. You see how the slope increases? So it reflects that. This is like x squared, let's say, this parabola. So yeah, that's how you do derivatives, guys. Thank you for listening to my lesson.